Okay, what we have here is you need to be aware of the fact that this is actually a solid object. It's not a triangle, it's not a half circle, it's a three-dimensional object. I'm also going to draw to your attention that we do have a formula and tables book, and this is on page 52 of the formula and tables book, and it tells you here that the distance of the center of gravity of a hemisphere, where is it now? Solid hemisphere, is 3/8 from the center of the hemisphere. So it's 3/8 from here going down. So the formula is there in the formula book. In terms of a cone, here it says here, we've got a right circular cone. We've been told that it's 1/4 of the distance from the base of the cone. So, we're going to be using that information in order to solve this problem and making reference to that later. Okay, now the next thing is we're going to adopt the same approach as we did before. So we are going to be filling in a table, and we're looking at this table is actually too big, so we won't be using the last line. We're going to be looking at 2 objects, not 3. The objects are a cone and a solid hemisphere. So we've got here, we've got our object. We're going to have not weight. We're going to use volume, because if you read the question, the shapes are all uniform. And here we're going to be looking at coordinates. Now, the objects we have is going to be, top object is a cone. The bottom object is a hemisphere. And what we have here is a composite body, which is made up of object 1 plus object 2. Now what we have is we need to work out the volumes. Now the reason why we can use volume in the sorting out of this problem is we were told that the wood had the same density throughout the object. So therefore we can treat volume as we would treat weight, and that makes the problem so much easier. So over here I'm looking at the volume of a cone, and the volume of a cone is equal to 1/3 of the base area times height. In your formula books, the volume of a cone is quite simply 1/3 pi r squared h. From the question itself, we know that r for the cone is equal to 12, and we were told that also in the question. From the picture, we know that the height of the cone is 12, and again we were told that from the question itself. So all we've got to do now is sub that in. So we've got 1/3 on pi on r, which is 12 to be squared, on 12. So Has anyone got a calculator? And give me the answer for that, please. Anyone?
576 pi.
Is that you, David? Who was that?
David.
Thank you very, very much for that. So we've got 576 pi centimeters cubed. Now we're going to work out the volume of the hemisphere. And again, if you go to the formula book, the volume for a sphere is equal to 4/3 pi r cubed. So therefore a hemisphere is half of this. So it's a half of 4/3 pi r cubed. So therefore it's going to be 2/3 on pi on, now the radius is 12. So it's on 12 to be cubed. And again, I would appreciate someone had a calculator to hand. I think it's going to be 1,152 pi? No?
Yeah. 52.
50.
1,152 pi centimeters cubed. Is that correct?
Yeah.
So now I can fill in these two sections here. So this is going to be 576 pi. This is going to be 1,152 pi. And someone could help me out here. I think it's going to be 6 plus 2 is 8. 7 plus 5 is 12. 5 plus 1 is 6, plus 1 is 7. And it should be 1,728 pi. Is that correct?
Yes.
Okay. All right then. Now what we're going to do is we're going to use a coordinate system. Now they've been a bit irritating because they've actually, I think, asked it. They want to find it, assuming that the wood throughout. Oh, sorry. I didn't answer the first one quite yet. It says here, prove that the volume of the hemisphere is twice the volume of the cone. So I need to prove that volume of hemisphere is equal to 2 times the volume of the cone. So right hand side is equal to 2 times 576 pi, which is equal, of course, to 1,152 pi, which of course is equal to the left hand side, therefore proved. That strikes me as being a bit silly. Okay then, now on to part 2. Assuming that the wood throughout has the same density, find the distance from the apex P to the center of gravity. So what I have decided to do, rightly or wrongly, what I've decided to do is I am going to draw my axes in red here. There is my x-axis, and this is my y-axis. Now I am deliberately choosing positions for my axes which make my life easier. So that's why I have chosen that. You can choose the axes to be wherever you like. Now, could someone please open up page 52 of the Formula and Tables book? Please don't be shy. Who's got one handy? Anyone? Hello? A no would be fine. Hello?
I don't have them. Okay.
Well, that's grand, because what I'm going to do now is I'm going to have a look at it here. So it says here, the hemisphere is 3/8 from the center. So the hemisphere is 3/8 from the center, and the right circular cone is 1/4 from the base. So I've had a look at the formula book, and the hemisphere is 3/8 from the base. Was that correct? Or do I need to look at that again? I think it was correct. It was, oh, I've lost it. 3/8. Just my luck. I pushed it too far off to one side. So there we have it again. It is 3/8 from the center of the hemisphere. So it's 3/8 from the center of the hemisphere. Okay. So what do I know? I know that the hemisphere has got a height of 12. So what we have now is distance from the origin. The coordinate is going to be, it's going to be down there, and we know it's going to be 3/8 of 12, and 3/8 of 12 is going to be 36 divided by 8. What's 36 divided by 8? I think you're
4.5.
I think you're all asleep this morning. What have I done wrong there? 3s into 12 go 4. 3s into, sorry, 4s into 12 go 3. 4s into 8 go 2. 3s are 9. So it's 4.5. Now, because it's below, and it's also a y coordinate, then we know that the coordinate for the hemisphere is going to be 0 along and minus 4.5 down. 0 along and minus 4.5 down. Now we're going to look at where it's going to be for the cone. Don't forget, this is a three-dimensional shape. So we're going to look at where it's going to be for the cone. And if you remember from the formula, it's actually 1/4 of the way up. So the center of gravity for the cone is going to be 1/4 the way up from the base. which means it's going to be 1/4 of 12, and 1/4 of 12 is 3. So again, because the thing is perfectly balanced in symmetry, the x coordinate for this position is going to be 0, and the y coordinate is going to be 3 up. Well, no one's screaming, so I'm going to assume I've got that correct. Now, because those two x coordinates are 0, we know by inspection that the coordinate for the center of gravity will also be 0. So all we have to do is work out y bar. So same as before, we've now got 1, 7, 2, 8 on y bar is equal to 5, 7, 6 pi on 3 plus 1, 1, 5, 2 pi on minus 4.5. I missed off the pi here at the front, my apologies. The pi's cancel, and 576 goes into all of them. 576 goes into 1728 3 times, so we've got 3 y bar. If you spot that, just makes the mathematics easier. 576 goes into itself just the once, so it's going to be 1 on 3, plus 576 goes into this twice, so it's going to be 2 on minus 4.5. So we've now got 3 y bar is going to be equal to 3 minus 2 lots of 4.5 is going to be 9. So 3 on y bar is going to be equal to minus 6. So y bar is going to be equal to minus 2. So basically, the center of gravity is a distance 2 below the x-axis. So what's the value thereafter? Because if you read the question very, very carefully, it makes it very clear that they want the distance from the apex P. So you've got to be really careful here, because what you've worked out is that the center of gravity is 2 below the x-axis, and P is up here, which is a distance 12 above the x-axis. So therefore, to finish off, the distance from P is going to be what? Are you all still there? 14 centimeters. Sorry to squash it all into one page. Any questions?